Alright, we're back for day 2 on section 6.1 on discrete and continuous random variables. And today we're going to investigate simply just the continuous random variables. And kind of explain the difference between the two. Discrete random variables commonly arise from situations that involve counting something. There is a finite number of events that we can actually count. Situations that involve measuring something often result in a continuous random variable. Heights and weights tend to be categorized as continuous random variables. Something I always think about is something that you can always put in between. For example, I could find somebody that weighs 200 pounds, somebody that weighs 201, and somebody that weighs 200.5. I can keep putting something in between, so it's very hard to count those situations. Where discrete is simply just I always think of something like shoe size. You've got 9, 9.5, 10. We don't have any shoe sizes in between those, so therefore shoe sizes are discrete. So a continuous random variable x takes on all values in an interval of numbers. The probability distribution of that variable is described by a density curve. And remember, a density curve, again, has to be drawn above the horizontal line, and the area underneath the curve has to be 1. The probability of any event in that area under the density curve and above the values of x that make up the event. Okay? So the normal curve is really what we're going to be looking at a lot in this situation, and we've had a lot of practice on that in the past. So the probability model of a discrete random variable assigns a probability between 0 and 1 to each possible value of x. The continuous random variable y has infinitely many possible values. So all continuous probability models assign probability 0 to every individual outcome. Only intervals of values have positive probability. So there itself, again, you cannot, in a continuous random distribution, you cannot find the probability of a single event. It has to be an interval. So, for example, we'll go back and look at our normal probability distributions. And this example happens to be the heights of young women. That closely follows a normal distribution with a mean of 64 inches and a standard deviation of 2.7 inches. Now, if I were to choose one woman at random, and let's call her height y, her unknown height y. If we repeat the random choice very many times, many times, the distribution of the values of y is the same normal distribution that describes the heights of all young women. So we want to know what's the probability that the chosen woman is between 68 and 70. Now we know, again, in our normal curve, our mean right here, our mean right there is 64, and then again a standard deviation of 2.7. We're interested again in finding this area right here. So again, always remember, draw the graph and shade the area of interest that you're looking for. So I'm going to show two different ways. One by using the z-chart in calculating z-scores, and then I'll finish with the calculator as well. So again, the first part of any problem is just to make sure you understand the problem right and state the distribution and the values of interest. So again, putting in our mean right here of 64, and then our standard deviation of 2.7. And again, we want to find the probability. And we want to find the probability that the young woman chosen has the height between 68 and 70 inches. So let me start doing our work. We can get the standardized scores for these boundaries. Again, taking our score of interest, the 68, minus the 64 divided by the standard deviation, and that z-score is 1.48, which we'll look up in just a minute. And also look in the z-score for 70 as well too. So 70 minus the mean, its individual score minus the mean divided by the standard deviation is 2.22. So what we'll do is we'll look up these values and go to our calculator, or to the z-scores, sorry, on the z-charts. And again, we were looking up the scores of 1.48 and 2.22. So 1.48, I'm going to scroll down to our table. So 1.48, 1.48 is 0.9306, and you can see that that's done right here, 0.9306. And then our other score that we're looking up on our Z chart was the 2.22. And 2.22 was right here at 0.9861. Okay. So I guess, sorry, 2.22. 2.22, so that's 0.9868 right there. Okay. So, you can already see ahead here on the slide, if I pick up where we left off. Got those different z-scores. Again, the 2.22 was 0.9868 on the chart. The 1.48 was 0.9306 on the chart. Subtract those two values to find this. This here is the probability, or the area, underneath the curve from 68 to 70. Now, we can also do this with the calculator. That's what I want to take a look at here as well, too. And if we go to our calculator, we would go to the calculator portion, go to menu, we can go to probability, to distributions, and then normal CDF, so normal continuous distribution function. And again, from my conversation earlier, we can't find the value of a specific value under a continuous curve, so that's where my argument is on this calculator, why we have normal PDF. So there is what they do is called a continuity correction that we'll learn way down the line, but we'll never use this. We'll never use the normal PDF because we're not going to find the value of any value underneath a normal curve. The specific value is 0, so that's why we'll be using the normal CDF. Our lower bound in this problem, again, we're back to this problem, and we were trying to find the lower bound was 68, and the upper bound was 70. So 68 to 70. Our mean, if we go back to our problem again, our mean was a distribution of 64 with the mean and a 2.7 for the standard deviation. So 64 and 2.7. And if we press OK, we can see that our value of 0.056105 compares very favorably to the answer that we got right here, just rounded differently to 4 places here using the z-chart. So, after we pick back up, we can see the values that, the different things we should have learned in this section. Again, you should be able to compute probabilities on a discrete random variable, be able to calculate the mean and the standard deviation of a discrete random variable, and then also compute the probabilities using the probability distribution of certain continuous random variables. In other words, making sure you know how to use the normal curve. So, with that, good luck on working on the homework, and we'll take questions after you've attempted each of those problems. All right, talk to you later.